So let's move on with our Matlab fundamentals, and we're gonna work more with vectors and matrices and try to reshape them so they can suit our needs. So essentially, there's often, so one thing that we're concerned with right now, and we will be for today, is representing my data, reading it in, trying to save it, and manipulate it. Because I have data in certain format, but that format might or might not suit my analysis, what I want to do with data. I got the data from somebody else, so I gotta kind of read it and figure out what it is, and basically analyze it. So one tool that Matlab allows you to do is reshaping your matrix. And this will be very useful in your homework because you're actually going to be reading in data from that is essentially bell logs, and they're saved in a certain way. You don't decide how they're saved, right? So you have to basically live with somebody else's design, but you're tasked to do something with it, so you need to know how to manipulate, and that's what we're going to learn today. So here's an example before we switch to real data that has like a lot of data in it. Let's practice with some simple stuff. So here is an example, and feel free to type it in. I will follow in a moment, but I will first explain what it is. So here's my matrix A that has 4 rows and 3 columns. So technically it's 4 by 3, therefore I have 12 elements. Since I have 12 elements to work with, 12 is 1 times 12, it's 2 times 6, it's 3 times 4, 4 times 3, 6 times 2, and 12 times 1. So that's how I can represent 12. So I can actually have options. How will I display these 12 numbers? And let's say that I would like to reshape my data for whatever mystical reason I have right now to do that into a 2 by 6 matrix. There's actually a built-in function, reshape, that will actually reshape my matrix A into a different shape as long as I have enough elements to go by. So since I had 12 elements, 2 times 6 is 12, so I can do that. And the way it does that, you tell it how many rows, how many columns. It's actually going to start from the first column. Okay? Say, this new column, I have 2 rows, so new column will have 2 elements. So it's going to read these first 2 elements and put them in the first column. And then continue. Second 2 elements, second column. And then it's going to continue column by column as if I had this many. So this is simply how reshape works in Matlab. So give it a try. Again, I have to have enough elements. So if I had 12 elements, then number of rows times number of columns has to be 12. As long as that is true, that is going to be fine. So I'm going to do diary. And this is Matlab fundamentals. Today is 5th. Okay. Yes, I'm going to record what I'm doing. And my A is 159, 2, 6, 10, 3, 7, 11, 4, 8, 12. So now if I say B, reshape A to 6, I'm gonna, again, since I have only 2 elements in my first column or any column of this B, I'm gonna take these first 2, 1, 2. That's gonna be my first column. Second column is gonna be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's my B. I can play with this, so I can actually try, well, how about I do 6 too? Okay. Then I'm going to take my first column, what used to be first column of A. There was 4 elements. That's not enough. I need 2 more. Okay. So I'm going to just keep going in the second column and take 5 and 6. So this is my first column.
and second column is everybody else. So basically I kept going 1, 2, 3, 4, 5, 6, then I stop, then I redo another column, 7, 8, 9, 10. So I just go in this order and fill out my new matrix. Yes?
Can you do the same reshape, but have it go from left to right without having to transpose the matrix first?
No. That's just how reshape works. So then you would do transpose first, and so you can do multiple things.
Now let's just see, let's make a mistake, and let's say I want to do 16. Boom. Oh wow, how my sound is on and it's going to the speakers. All right.
All right. So basically, reshape, the number of elements must not change.
So the total number of elements should be correct. Can I do less? So in this case, I have 5 by 2 is 10, which is less. So I have enough elements. Let's see if it's going to do that. No. So reshape
has to have the same number of total elements. Though in this case, technically, it could have been programmed to say, well, okay, take 10 elements and discard the rest. But that's not how it was programmed. So part of it is that you have to know, this is the point I'm going to make throughout the semester, is that there is sometimes multiple choices about how something could be designed to go. Okay? And somebody made that choice and built it in. You kind of have to know so that it doesn't bite you in certain situations. So basically, you do have to know what it is that whoever was programming, was putting in.
All right. So that is reshaping.
I can also do reshape in a column, and if I just wanted one column of elements, okay, I can do a shortcut, and I can just say, aha. So you can actually create that from matrix A that we just typed in. There's no need to do this. But basically, if I just say, aha, just shift this entire matrix into a column, I can do it this way. So it's just a shortcut for reshape number of elements, comma 1, right? In which case I'm going to have one column. So basically,
if you try this with the matrix A is just all of the elements in one column, okay? Which is same as reshape A 12, 1. Yes? So these are two equivalent ways, so this is just a shortcut. Questions? Okay. Simple so far.
Okay, so I'm going to temporarily skip strings and polynomials. I'm going to come back to it after we go through saving and loading data because this is going to be a major part of your homework. So I just want to make sure that I go through this and have time, and then I'm going to go back to strings. Okay? So let's now learn how do I save my work in a permanent way, which means in a file. And file I can exchange and send to a friend of mine, and then they can do something with the data, send me the file back, and so forth. Now files, in general, you are very familiar with. There's a Word document or Excel spreadsheet that you probably worked so far already. Okay, PDF documents. Okay, all of those, the moment you have a very specific extension, that means that file format exists. Okay, and a particular software knows what to do with that type of file. Okay, so for instance, .docx, which is a Word document, Microsoft Word, and a number of other editors, so OpenOffice editor, or there are editors on Mac that can do it too, do know how to read .docx. But they know that because you're following a specific format. For some reason, I'm still not. Okay. So because, okay.
I know what will solve that. Close tabs. Okay.
All right. So they know that because they know what the format is, so they're going into the file and they're reading things one by one based on that format and knowledge of that format. Same happens with anything that has a specific extension. For instance, images are .tiff or .jpeg, .png, there are different formats. Again, format means that a standard exists so that the program can go in and read the file. One of the simplest formats, and that's the only one that we can actually just read, are text files, where when you open the file, what's printed in the file is in a format that humans can read. Nothing is really saved on the computer as text. Even in this case, data is saved in a binary format. You have bits that are 0 or 1, okay? And you have a certain number of bytes that you're taking to save the data. It's just that there is this ASCII code that translates those bytes and bits into letters. And sometimes you have tables that translate that data, or those numbers. And basically a certain number will be letter A, certain other number will be letter B, and so forth. Sometimes when you get like an email from a different country that is using different letters, your computer might not know what to do. Okay. So what happens to me, the ch at the end of my last name, Pradanovic, is one special character that you need to have a table to translate it. And if for some reason your computer doesn't have that table, then you will get a bunch of just garbage at the end of that, my Pradanovic essentially, because there is no translation table. That happens just with a couple of letters in my name, but if it was actually something that is coming from China where everything is different, okay, then you don't read anything, and we can't essentially decode a lot of emails in there in a completely different language, and we don't have the appropriate tables. Okay? So you have to understand that whatever is saved on your computer is essentially in a binary 0-1 format, and your computer has to know what to do. Text files are very simple ones where it's a very simple table to just present something, whatever you have in memory as text, but the text should make sense. So we will learn how to save things in different formats. First one, where everything is simple and solved for us, is .mat, which is Matlab format, but only Matlab can read it, or some environment that is Matlab. So if I just create a bunch of variables, and I can say, save my file, okay, then there will be a file called myfile.mat created in the memory that will save all of these things in memory. And I can load that back in. So let's give it a shot. This is the simplest and sort of the most elegant way that works only for Matlab.
So what I will do is I will indeed create, so I will actually clear, so this is what I have in memory right now. I'm just gonna clear it all, okay? So I don't have any stuff that I don't want. And I'm gonna follow basically instructions here. So I'm gonna create A is 2, X is 1, 5, and Y is 5 times X. So I can see that they have showed up in workspace. So if I want to save them and share them with somebody, the simplest way is save my file. And I will see that my file .mat has showed up here. Is this file human readable? It's a special Matlab file, so only Matlab can open it and read it. If you open it, it's gonna not make sense, okay? Now, I'm just gonna now clear all of the variables. So A, X, U don't exist anymore, okay? And no matter how many times I say do not have sound, my computer will still send sound to that. So what I want to do is I want to now bring these back, and I'm gonna just say load my file. And since I am in MATLAB and that was a MATLAB file, MATLAB will know what to do, and these three variables will appear again. Okay? But if I wanted to go to a Word document and open myfile.mat, it would make sense whatever is written there. Yes?
What is the difference between this and .m?
.m is actually a text file that is readable as a text file. So you can open it with a lot of different software. Okay?
But
And it doesn't save the data itself, but the code or the text. Okay? So these are variables. They're variables and they're numbers. They're interpreted as numbers. If you just write these, if you write this as a text, it's not those numbers. It's that text. It's the command. Okay? So that's the difference. But .m file, if I save it, so there is a difference in .m.
If I wanted to save this as a, let's do that. I'm going to say new script. And I'm going to save this as a command. And I'm going to say save as. I'm going to say myfile.m. Okay? This is now a MATLAB script. It's interpreted as such. .m files are text files, so you can open them in any text editor. So this command is saved. Okay? So I cannot now, if I clear all, I could load my file because that's where I store the data. Okay? I cannot load my file.m, but I can execute it. I can just say my file. And now it's going to look for .m file because and it's essentially going to execute that one line that creates these three again. Is everybody clear on the difference between the command and actually saving the data? Yes?
If we want to load a file and it's not in the current folder that we have loaded up, can we drag and drop?
You should be able to, yes. Can you give it a try? Yeah, I think so. So essentially for everything, when I type in my file, this is a command prompt. Okay, so it's expecting a command. That command better be loaded in the standard places where MATLAB keeps its commands. So for all of the commands like load, there's a load.m file somewhere in the memory where MATLAB knows to go to. Okay, so it knows what to do. It's executing that script. Okay. If I type in my file, it's going to expect that my file to be on what's called on my path, somewhere where I know where to go. And my directory, my current directory, is always on my path. Okay.
So if I remove this file, let me see if I can just delete it. I can delete. Okay. So if I now want to say my file, it's going to say
Undefined function or variable my file because the script doesn't exist in the current directory anymore. Or any other directory that this MATLAB knows to go to. Okay? So you have to either change to that directory, or you can also add path or the directory path to the directory you want to this list, and we can do that later. Okay. So but again, there's a difference between
.m files and .mat files. All right. So this is the simplest way. This is sort of built in with MATLAB and works only for MATLAB. But the colleague you're sending data to might not have MATLAB. But everybody has something on their computer that reads text files. So text files are the simplest ones to exchange, even though in case of really large files, that's a waste of memory. Okay, you don't want to send a 1 gigabyte text file. That's a bad idea. Okay, so because anything else that is binary will be at least 8 times smaller. Okay, give or take. Okay, so you don't want to always waste memory with text files, but if it's small enough, then text files are perfectly fine, and everybody can read them. So if you actually want to save file, you have to actually add this dash ASCII. ASCII is the code ASCII. It's American standard for coding something something. Okay, somebody could actually probably do a search and find what ASCII stands for, but it's this code that translates things to text. So I have to tell it save this as a text file. I can also pick and choose variables to save. So for instance, I could save in test1.txt.
I can save X and Y only and not A. Okay? And this is the way to tell it to save a text file, and then I can open that text file as a notepad, and you will then see these numbers written into the file. However, when you save things in text file, so it's just saving these numbers, it's not going to know the name of these variables X and Y. So if you try to load this text file, it's not going to recreate X and Y under those names. And this is where loading things and that reshaping of matrices can help, because you can grab the data. So let's actually play with this.
Okay. So I have a and x and y, and I'm gonna say save test1.txt. And often text files are also .dat files, which comes from data. These days I've seen Windows machines complain about .dat because apparently it's reserved for something else, so then it misinterprets the file as something else and not necessarily text file. You have to be careful about that. I like txt because it's text, so I know what that is in there. XY, and I'm gonna say ASCII. Okay. So now you will see test1.txt show up. If I open this file, Matlab will also open it, okay, and it has saved it as numbers, just numbers. Matlab will open it as a text file itself. I can also just say type test1.txt. So any text file can be typed, and type is a command which just spits out what the text file is. Now I will clear all of the variables, and I'm going to try to load that text file. How did I call test?
And what it loads it as, if I don't tell it otherwise, it's going to call it test1 because that's the only name it knows. The only thing that got saved in the file is just the numbers themselves. Okay.
So my test1 is a matrix.
All the numbers that it read from the file. The difference clear between the saving. And this is where I might want to manipulate or reshape or do something with this matrix depending on what data is. Now I know the way I save things. This was my X. And this was my y, okay? Because y was 5 times x, if you remember executing.
So the way I would do that, it's Zizou?
Okay. Did I butcher your first name completely?
Oh, I go back Xavier, so.
I can call you
Xavier?
Xavier. So can you tell me how would I get my original x from this matrix?
So how do I refer to the first row of the matrix? Yeah? Do we remember that from last time? So this is my x, and then can you now tell me what y will be?
2.
So this is the second row. Okay. If I, for some reason, wanted to grab, I'm going to call this Z, the first or the third column of test 1, then Carter, Hannes. So Carter, can you tell me how to grab third column of test 1? Three would be third row. We don't have the third row.
3.
So that's actually element 1, 3. Okay. To get the entire column, I would have to have that. And then I'm getting the column. Does that make sense? So this is what my test one was. This is the third column. To get the entire third column, I have to say colon, and that means everybody in that column. Okay? If I just say 1, 3, that's element 1, 3, that's 3 in this case. Yeah? Okay. So these are very useful to get the elements and then work with them and do something with them. Okay? All right. So again, this is just like when I'm learning. This is basically the format of what I just did here. So I can just load the file name. If this file was a Matlab file, .mat, I don't have to put .mat. I can omit it, and it's going to know what to do. If it's a text file, I have to put .txt, but then it will basically load the contents of this text file into a matrix that I have to manipulate later. So Matlab file actually saves the variables the way I had in the workspace, whereas text file will just dump the numbers into the text file. Okay? So you can read again the way you load is what we just did. So this is just one example on the. I'm not gonna repeat this because we essentially did it already. All right. So this is input and output. And this was a simple input and output. One was the built-in way for Matlab. Second one was the text files that everybody knows how to read. Well, I can actually go binary as well, okay, and read and write binary files. But they're a little more complex in the sense that I have to follow a certain procedure. So let's do that. And sometimes my text files could also be a little more complicated. So if I load them up, it's not gonna everything, as long as not everything is just a matrix of numbers. I could have text in there that I want to be recognized as text. So I need to actually know what I'm loading in. So let's take this to a little more complex level. Okay. The essential command that tells Matlab, go to this piece of memory where my names of files are really memory addresses. Okay. Go to it. And go to the beginning of the file and be ready for reading or writing or something, doing something with the file. The command that does that is fopen. Okay. So what I'm doing here is I'm saying F stands for file. File ID, FID, is file open, fopen. This is file name of the file, and you also design a permission you want to give for opening. I could open it for reading, I could open it for writing, appending, and so forth. So basically, I'm gonna go and we're gonna give it an example. We're gonna first say, okay, open this file for reading. And the permissions that you could give is read, write, and append. So you will download a file that needs special manipulation like that. There's a PDX T head, which is temperature head, .dat, and it's shared in Matlab folder on Canvas for you. So go please download it. And this file needs special care because the first line of it is human readable and it's text, followed by data that we actually want to manipulate. And this is very common, and you need to deal with it. So go and find that file and open it. And we will actually use this special. You can open it in a text editor and look at it, look at the contents. But in order to get rid of that first line, which is not the data you want to analyze, we need to kind of follow the procedure. So you can first tell Matlab, okay, go and associate. You need an ID here because you might have multiple files open. So you're going to say open pdx thead dot that. I'm just going to go with read. This is simply for reading.
Do I have it? Did I actually? No, I don't have it. So when you don't have the file, you're going to get a negative number, and that's going to tell you, it's not in your folder. So for me, it's in some other folder.
I'm actually just going to quickly, instead of searching where it is, I'm going to just quickly download it myself. Okay. Full screen download. Okay, and I'm gonna save it. And this is the where I am. So you have to, when you download, save in the current folder. So now it should show up. Here it is. Okay. So now when I open it, I'm gonna get a positive number. Okay. So positive number means file is open correctly. Negative number, typically it's not open, typically because you don't have it in the folder that Matlab knows about. Okay. Okay. Now we are ready for reading, and I want to first get rid of that first line, which is just text. And the way you do that is I'm gonna say headings is fgetLine. So this is in this FID, so basically FID is the, oh, hi. So headings is just text. And I'm ready for the numbers. And numbers, to scan them in, I'm going to just scan them into D, which is just an array. F scan F, so basically file scan this FID, which is the ID of the file that I'm reading. And then I have to follow with format. In this case, there is integers and there is real numbers. So in order to tell Matlab that I have real numbers, actually, I do it this way. This means that I'm telling it the data type, and this means float. Floating point is a real number. Yes?
I think I did something wrong. So I downloaded the PDX thread into my folder.
Yes.
But and then what I did was like numbers and buses. Because I just
Yes, you misspelled the name of the file.
Oh, and so that would still give negative one.
So if you
wouldn't say no file.
No, it's just gonna tell you. So what he did is he put an R here, hread or something like that, and that file doesn't exist. Okay. So the moment the file doesn't exist, you're gonna get a negative number. More questions?
Oh, what's after on your headings equals F get? What's the letter after the T and get?
L,
Okay, it's L.
as in line. So this means file get line. So it's gonna get one by line, and you can actually read the entire file like that, but it's gonna read it into a text. So that works very well for text, but not for anything else. So after that, we want to switch for numbers. So what I'm pointing here is that you actually have to have file in front of you and know what you're reading. This is a text file. So the first line I want to read as text, and the rest of it I want to read as numbers, and I have to tell Matlab that. Okay? Computer does only what you tell it to do. So when there are problems, it's because your instructions were not clear.
And one of your jobs as an engineer is for your instructions to be clear. Whoever it is that you're giving instructions to, a computer or a person. Okay? So D is now saying, okay, file scan for basically numbers, and these numbers could be floating point numbers, which is F. Okay? So those are real numbers. Okay? So when we do that, luckily, we don't have to tell Matlab how many numbers to read. It's just going to go and read as many as it can find until it hits. There is a little mark at the end of every file marking the end of file. And when it hits that, it's going to stop and return. Okay. So luckily, we don't have to go and count how many numbers are there because we don't always know that. So we're going to say, well, in other programming languages, yes, you actually have to count. Smile. In this one, you don't have to. So it's just going to read until it can. So all of these numbers are now read into D, and my D has 48 numbers. Okay? I can see it here, or I can say size of D. Okay? So all of the numbers are done. And I'm done with the reading the file. I'm going to reshape and like kind of clean these numbers up, but I'm just going to say if close, file close, FID. I'm going to tell you right now on the test, if you forget to close the file, I'm going to take points off. Why? Because this is how files get corrupted when they're not properly closed. You know how sometimes you try to open some file and it says, oh, file is corrupted? That comes from not closing the file properly for whatever the reasons might be. Okay? So it's not taking care of your data correctly. Therefore, I typically take points off when you don't close the file. So when it closes it correctly, now it's 0. And now you can't really touch the contents of that file, so the contents will be preserved the way they are. Okay? So let's now see the numbers. So these are the numbers D. I want to reshape them. Let's remind ourselves, how does this file look like? So I have first column, which were numbers 1 through 12. Then I have the second column, which was the high temperature. Okay, probably this is like month of January or February in Austin. And low overnight temperature, this is like, okay. Though I think this is probably by month, okay? So I don't think, let's see, this is not Austin, highs are not in 80s. So we need hundreds here, okay? So it's someplace, somewhere. It's not terribly cold because 33 is not quite freezing. Freezing is 32, okay? Not terribly cold, and this is an average temperature. These are temperatures. We need to plot them or interpret them as such. The problem with reading files is that the way it's going to read the numbers is going to go row by row, not column by column. So that D, and we can check that in a second, that D has numbers like in this order. Okay? So I kind of need to manipulate it because ultimately I want to plot my high temperature versus month, or my average temperature versus month. That's what I'd like to plot. Okay. So I have to now reshape my D to be in the format that lends itself to that. So if you see first 4 numbers of D, D 1 through 4, they're actually, in this first 4 numbers are actually going to be my first row, but they're kind of like, and then the second 4 numbers, if I go to 8, I can see first row, second row, okay? So I need to manipulate that to actually get a vector. I want a vector of months 1 through 12, a vector of high temperatures, low temperatures, and average temperatures. So how can I reshape this? Okay. Here is one way. I'm going to say reshape D. I'm going to call it D1 for the lack of better. My original D. So I know that the way reshape works, it's going to read in things into columns one by one. So let's actually read these first 4 numbers that are actually a row over there. I'm going to read them into a first column, and then a second column, third column, and so forth.
Okay. So for this to be in the first column and this to be in the second column, what should be the shape of D here?
I have 48 numbers altogether. I want 4 per column, right? That's number of rows, 12. Okay. So my D, let's see the first column. The first column of D, whoops, D1, I meant D1, is these 4 numbers. Okay. So I can work with this. Essentially, my D, my first row, whoops, D1, so my first row is actually my months, right? 1 through 12. My second row is my high temperatures, 45, 50, 56, right? So forth. My third column, third row is actually these low temperatures, and then my last row is these averages. So this is something I can already plot.
If I really, really want my data to be precisely in this format, what can I do with that?
What can I do with D1? Transpose. So D2 is D1. This is if for some reason I really like working with columns. So my data that is of my interest is in columns. So here it is. So I'm going to actually say month is D2. This is my second one. So the first column of it is this. No. My D2, D1. Did I do this correctly? Oh, I didn't transpose. I was like, why is it? There we go. I forgot to type in the apostrophe. Okay. So then my month is D2, the first column. Okay. And let's say that I want to plot average temperature. That's my fourth column. So now I can plot month and average temperature. There we go. And I really, really don't like this default font size. The way to fix that, you can click and fix things like font sizes or whatever on this plot. So you can manipulate it that way. Or you can just say set GCA, this is the current axis. And I'm going to set the font size to be large as 16. And now you can actually read it. And one more thing before I let you go. I'm going to label x-axis as month. So I'm going to get month here. And I'm going to label y-axis as temperature. And here's a nice plot that I can save and put into my presentation and make my professors or bosses or the like happy. All right? All right? Email me if you have trouble with homework. Today I'll be available for office hours 3 to 4, and then unfortunately I have a faculty meeting at 4 to 5. So I'm going to send an email about that.
I was lost.